Hey guys, hope you're all doing good. In our previous videos, we have extensively talked about the launch vehicles ISRO currently uses. In this video, we'll tell you about the future launches of ISRO. In recent years, there has been a huge surge in the developments of reusable rockets. SpaceX has been spearheading the development of reusable rockets with its Falcon series of rockets. This has been instrumental in reducing the price of launching a payload into Earth's orbit. SpaceX Falcon offers to launch a heavy payload of 64 tons to low Earth orbit at $90 million. If you work the math, you'll realize that you can launch a payload of 1 kg in just under $2,000. Although ISRO doesn't release the exact figures of how much it costs to launch a payload of 1 kg to low Earth orbit, there have been speculations that ISRO charges around rupees 6 lakhs or 8,000 per kg of payload. This is much higher than the price of SpaceX. The main reason behind this is that ISRO uses expendable rockets, whereas SpaceX uses reusable rockets to launch its satellites. This drastically reduces the cost, as the same rocket can be used over and over again. Because of these reasons, ISRO has started research on reusable launch vehicles, or the RLV. The RLV is a lifting body spacecraft designed to be used again after launch. We've made a dedicated video on how lifting body aircrafts work. Do check it out, the links are in the description below. The RLV is a lifting body aircraft which is shaped similar to the space shuttle, and this is done to maximize the total lift that can be generated by the fuselage. It was successfully tested on May 23, 2016 from Satish Dhawan Space Center, Sriharikota. The main purpose of the launch was to validate the critical technologies such as autonomous navigation, guidance control, reusable thermal protection system, and re-entry mission management. RLV-TD was launched aboard a single-stage solid-fuel booster that was derived from strap-on boosters flown on India's Polar Satellite Launch Vehicle. By the time the booster consumed its solid propellant, the RLV-TD separated from its boost stage and peaked to a suborbital altitude of about 65 kilometers. The heat shield, guidance, navigation, and control algorithms were tested at hypersonic speed by accurately steering the vehicle during the descent stage. During the descent stage, the test vehicle was programmed to pitch its nose up to expose the silica tiles and the reinforced carbon-carbon nose cap to the airflow into the thick lower layers of the atmosphere. It reached a maximum altitude of 64.8 kilometers and a max speed of Mach 4.78. The craft splashed down at a distance of approximately 412 kilometers away from the launch site. The other interesting technology to reduce launch costs is scramjet. Conventional rockets launch satellites into orbit by multi-staged satellite launch vehicles like PSLV and the GSLV. But these launch vehicles are expendable. They also carry the oxidizer along with the fuel for combustion to produce thrust. To carry 10 tons of payload to orbit, the GSLV Mark III carries 350 tons of payload. This means that the payload is just 2% of the total mass of the rocket. Nearly 70% of the propellant carried by the rockets consists of just the oxidizer. So by eliminating the oxidizer, we can reduce the total weight and the launch cost of the rockets. One way to achieve this is by utilizing atmospheric oxygen for combustion. And also by making the launch vehicles reusable, the cost can be brought down significantly. Considering all these advantages, ISRO started the development of the scramjet engine. The scramjet engine is a type of engine which is capable of generating thrusts at hypersonic speed. We will be making a detailed video on how a scramjet works, so stay tuned. ISRO's first scramjet engine was successfully tested on August 28, 2016 at Satish Dhawan Space Center. ISRO used the Rohini sounding rocket to launch the scramjet to supersonic speeds before engaging the scramjets. Critical technologies such as ignition at supersonic speeds, air intake mechanisms, and fuel injection systems were tested. The rocket used liquid hydrogen as fuel. The scramjet had a powered flight for a full 5 seconds, where it accelerated to Mach 6 or 7,400 kilometers per hour. Recently, DRDO has also been developing the scramjet technology for the development of hypersonic cruise missiles. On June 12, 2019, the DRDO tested the HTDV, or the Hypersonic Test Demonstrator Vehicle, from Kalam Island in the Bay of Bengal. Well, that's it for this video, guys. Hope you found it useful. We'll meet again in the next one. Until then, bye.